This is the homework for 719, 721, 722, 723, and 724. In 719, we have two polygons that are similar, and we need to first find what is the scale factor. And so we're going to do the scale factor from big to small, the original polygon to the new polygon. And so we need to find two given corresponding lengths. And so we have this left side of the polygon and the left side of the corresponding side. And so if we're going from big to small, so the scale factor is the length of the new side, it's the new side, to the length of the original side. So we have 4, 6. So the scale factor can simplify to 2/3. So the scale factor is approximately 67 hundredths, but if we need the exact scale factor, we leave it in fraction form, is 2/3, because this is a repeating decimal. For the second part, we need to find the missing sides, z, y, and x. And so first we're going to start with z. And in order to find z, we multiply the length of the corresponding side by the scale factor. And remember, the scale factor is 2/3. So, and we also want to make sure that the scale factor is correct. We're going from big to small, and the scale factor has to be less than 1, but greater than 0, because we're decreasing the size. So we have 2/3, the scale factor, multiplied by the length of the original side, which gives us 2/3 multiplied by 5.7, which equals 11.4 divided by 3. 3 multiplied by 1 is 3. 11.4 divided by 3 is 3 8/10. For y, we're going to do the same thing. For y, we have the original, and we're going to multiply it by the scale factor. The scale factor is 2/3. It's going to decrease in size. So we have 12, and I wrote it as an improper fraction, 12 over 1, didn't change the value, multiplied by 2/3. 12 multiplied by 2 is 24, 1 multiplied by 3 is 3. 12 divided, 12 divided by 3 equals 8. So the length of y is 8 feet. The next one we're going to do is find the value of x. And so there's a couple of ways we're going to do this. We have x multiplied by the scale factor equals 6. Or we can find the scale factor from small to big. It's going to increase in size. So if we find the scale factor from small to big, we can multiply 6 multiplied by the scale factor to get x. So what I'm going to show you is I'm going to show you how to find the scale factor from small to big. And so the small will now be the original, and the big will be the new. So we have the length of the new over the original. And since we're going from small to big, the scale factor is going to have to be greater than 1 because it's increasing in size. So we're going to go ahead and take the same two corresponding values that we had before, but instead of 4 over 6, it's going to be 6 over 4, because the new is the small. The new is the big, and the original is the small. We're going from small to big. And so we get a scale factor of 6 divided by 4, which equals 1.5. So now we can take the value of this side, which is 6 feet, and we're going to multiply it by the scale factor, and it has to be greater than 1 to get a larger value, which we get 1.5, the scale factor, multiplied by 6, which equals 9. So x equals 9 feet. For number 21, we need to solve the system using any method. Well, both of these are in y equals form, so I could use the substitution method where if this is what y equals, I can plug it into this equation, right, or into y. But if you look at both of these terms right here, this is the slope. And so the slopes are both negative 2/5. Well, if the slopes are the same, the lines are parallel. They do not intersect. There's no solution. So we really don't need to solve this system because we know that there's no solution because these are parallel lines. And what does that look like? It looks like this. Here's the first equation. Y equals negative 2/5 plus 1. 1 is the y-intercept. And rise to negative 5. And then here's the second equation at negative 1. Y-intercept is at negative 1. Rise to negative 5. So the solution to a system is when or where these two lines intersect. Well, since they are parallel, these lines will never intersect. They have the same slope. For number 22, we have triangle ABC at A is at negative 2, comma 7, B is at negative 5, comma 8, and C is at negative 3, positive 1. And what we need to do now is reflect across the x-axis. And so when you're reflecting across the x-axis, here's the x-axis, they're going to be equidistant from the axis. So C is positive 1, C prime is going to be negative 1. A is going to be positive 7, A prime negative 7. B is going to be positive 8, B prime is going to be negative 8 units from the x-axis. The second part, part B, now we need to rotate triangle ABC prime 180 degrees. And there's two ways we can do that. One, we'll actually rotate the paper. And it doesn't matter if you go clockwise or counterclockwise for 180 degrees because it ends up in the same location. So here's a 90 degrees clockwise rotation, 180 degrees clockwise rotation. And so here is where my rotated image would be. And so now what I can do is take the coordinates down, and for C prime, it would be positive 1, 2, 3, and then positive 1. And then I could rotate my image back, my graph back, and I'd go positive 3, 1, 2, 3, positive 1, and then there's going to be C double prime. And I can do that for each one of them. Rotated 180 degrees. Here's B. B prime is here. 1, 2, 3, 4, 5. And on the X, 1, 2, 3, 4, 5, 6, 7, 8 on the Y. Rotate it back. 1, 2, 3, 4, 5 on the X. 1, 2, 3, 4, 5, 6, 7, 8 on the Y. And there's going to be B double prime. And then we go ahead and do A, rotate it 180 degrees. 1, 2 on the X. 1, 2, 3, 4, 5, 6, 7 on the Y. 1, 2 on the X. 1, 2, 3, 4, 5, 6, 7, 8. Actually 7, so positive 2, positive 7. And if you look at the coordinates, when you do a 180 degree rotation, the coordinates are just the opposite. Opposite of a positive negative 2 is positive 2. Opposite of a negative 7, positive 7. And so you're just doing the opposite coordinates when you do a 180 degree rotation. And there's my rotated image, 180 degrees. Part C, I need to describe a single transformation that would map triangle ABC onto ABC double prime. So if you look at these two, it's a reflection of each other. So to map it means to lay it on top of the other. It's just a reflection. So we're going to flip or reflect over the y-axis. For problem 723, Nina has some nickels and 9 pennies in her pocket. So we're going to let n equals nickels, and here's Nina, and Nina has some nickels. So we don't know how many nickels, so we're going to use the variable n. But we do know nickels are worth 5 cents. And then we have and, so we're adding, and how much are we adding? The 9 pennies, so here's 9 pennies. Pennies are worth 1 cent. Her friend Maurice has twice as many nickels. So twice is 2 times as many nickels as Nina. So here's Nina. Nina has, we don't know how many, but we do know nickels are 5 cents. We don't know how many, but nickels are worth 5 cents. So he has twice as many nickels as she does. And we know together their coins are worth 84 cents. So Nina plus Maurice equals 84 cents. So now we can go ahead and simplify this equation. First, we're going to go ahead and distribute the 2. 2 multiplied by 5 cents, or 5 hundredths, equals 1/10 or 10 hundredths. So now we can combine like terms. We have 5 hundredths n and 10 hundredths n, which equals 15 hundredths n, or 15 cents, plus the 9 nickels. We distribute the 9 multiplied by 1/100th equals 9 hundredths. So now we want to get n by itself. We want to know how many nickels does Nina have, so that's what n represents, nickels. So now we're going to go ahead, inverse property of addition is subtraction, so we're going to subtract 9 hundredths from both sides, and we get 84 hundredths minus 9 hundredths equals 75 hundredths. Inverse property of multiplication is division, so we're going to divide both sides by 15 hundredths because that creates the giant 1. What you do to one side, you do to the other. 75 hundredths divided by 15 hundredths equals 5. So n equals 5. So how many nickels does Nina have? Nina has 5 nickels.